Live on WFLA Now. With a specialized degree in climate, Chief Meteorologist and Climate Specialist Jeff Berardelli is pioneering the way we look at climate and extreme weather. Welcome to Jeff's Climate Classroom, powered by ArmorView Window and Door.
All right, everybody, this is Meteorologist Jeff Berardelli. I want to welcome you today to the Climate Classroom. And we are here talking about Hurricane Ian. It is the anniversary of Hurricane Ian, 1 year anniversary of Hurricane Ian. Of course, it was the costliest storm in Florida history, the third costliest storm in U.S. history, and it was also a very deadly storm for the folks in Southwest Florida, but also in part of the Tampa Bay viewing area, which was the southern half of our viewing area down in Sarasota County. A brand new study has just come out, and it basically says that a warmer climate made the rainfall intensity in this storm much stronger. And so that is what my guest today is here to talk about. I want to introduce you to Dr. Michael Wehner. I got that right? Wehner, exactly. He's a climate scientist from Lawrence Berkeley National Lab, and we've had him on the show before. He's someone that I speak to frequently with all the latest climate and hurricane news. I want to thank you for joining me today, Dr. Wehner. Thank you for having me, Jeff. All right, so I want to first show everyone the storm that we're talking about, and we all remember it very well. That's Hurricane Ian. Came ashore as a strong Cat 4, but it was briefly a Cat 5 over the Gulf of Mexico right before it came on shore. So it did weaken just a teeny bit when it moved on shore. But one of the biggest impacts from this storm as it moved on shore was very heavy rainfall. You know, it was really a water storm, Dr. Wehner, more than it was a windstorm in terms of its impacts.
Indeed, and it was both saltwater and freshwater.
That's right. 15 feet of storm surge, pushing all those boats up on land and unfortunately causing a lot of damage and many deaths in the Fort Myers Beach area. But the aspect that you researched in your paper, which is actually, I should mention to folks that it was, it's already at a journal, but it hasn't been reviewed yet. Is that correct?
No, it's accepted.
Oh, it's accepted.
Yeah, and it should be out in about 2 or 3 days.
Okay, that's good.
We've reviewed the final proofs, made a few corrections to citations, and is ready to go.
All right, so I want to show everyone, first of all, the map of how much rain fell during Hurricane Ian. So I'm going to pull that map up for you. And, you know, the heaviest rain fell on the north side of the storm. There it is. Everywhere that you see the white and the gray, that was about 15 to 20 inches of rain, in some places even more than 20 inches of rain. So you went back and did a climate model study on this to figure out, did climate change contribute? And if it did, how much did climate change contribute? So can you tell me what the results were?
Well, the result is we found that climate change increased the total amount of storm precipitation by 18%, which is a large number. And greater than you might expect just from the increase in the available moisture. And that, I think, is really informative. That's telling us sort of indirectly that the winds are stronger because the storm, since the rainfall increased at a rate greater than atmospheric moisture did, the storm is more efficient at precipitating out the available moisture. And so that's sort of a recurring theme we've been finding. We've done about 30 of these storms now. And Jeff, I would correct you. We didn't really go back and do this. We did it during the storm. And that's sort of the thing that made this study different than the previous ones, is that this was essentially done in real time. We could have done it maybe, it was done when the storm was just exiting Florida. That's when we made the statements on Twitter, which were conservative statements. We could have probably done it a little earlier, but my colleague went out for dinner.
Well, you know, I think that's a testament to how far climate science has come, that we can actually do real-time attribution studies. I noticed, of course, that this was a real-time attribution study. So let me bring up just one of the graphics from your study right there, which shows the increase in rainfall from Ian. So can you tell people what they see on the left versus the comparison to what they see on the right?
Well, let's start with the right, actually. The right is our simulation of the storm that was. So it was, you know, at that point, essentially a forecast. And a competitive forecast with what the National Weather Service or National Hurricane Center would have put out. Probably not quite as high quality. Their models are really tuned to hurricanes. but it's okay. And then the graphic on the left is the storm that might have been had climate change not happened. And so it's sort of we call it a storyline, a hypothetical storm that might have happened if there hadn't been a degree of 1.2 degrees centigrade global warming. And so it's a sort of a case study. Of course, in the real world, two hurricanes never are absolutely identical in all aspects. And so
Right.
that kind of thought experiment is what leads us to our conclusions.
So the bottom line, and just to make sure we have this clear, on the right, that's a simulation of Hurricane Ian and how much heavy rainfall fell during it. And on the left is a world where the world has not warmed. It's essentially a counterfactual world that doesn't exist now because, of course, we've warmed the Earth by around 2 degrees Fahrenheit, but essentially in a climate that's around 2 degrees Fahrenheit cooler. That is the rainfall that's produced on the left. And clearly you can see, again, correct me if I'm wrong here, clearly you can see that on the right, the computer model simulates a lot more heavy rain due to a climate that in general, globally at least, is 2 degrees warmer versus the left where it's 2 degrees cooler. Is that correct? I'm sure there's more details though.
No, that's correct. I mean, and you could tell by looking at it that there's more rain in the world that was than the world that might have been without climate change. And that number of 18% more is just over land. It increases over the water as well. I'm doing some more research with some longer simulations across many storms and looking at this precipitation efficiency. How much of the available water comes out, and these numbers are really subject to change, but I'm finding that over water, it's like maybe 20% more efficient, but over land, it's closer to 80% more efficient. And that is, I think the main reason why we see such large numbers for the attributable increase in hurricane precipitation.
So we saw, again, over 20 inches of rain in a swath from the southern part of Sarasota County, straight through Hardy County, up into southern Polk County, even parts of Highlands County. That's a lot of rain. And over the course of 6 hours and 12 hours, it's like a 1 in 1,000 year event. So what you're saying is that climate change, a warmer climate, made this storm even wetter than it would have otherwise been. And what does that do in terms of impacts?
Well, I think it's important to remember that even without climate change, this would have been a very severe storm. I mean, instead of 20 inches, you would have had, 16 inches or something. I mean, whatever the numbers are. That's still a lot of rain. But the impacts the change in the impact is usually at the margins. And so, you look at the flood, and we did this for Hurricane Harvey. We haven't done it for Ian, but when we looked at Hurricane Harvey, we saw large changes in the flooded area for that, again, about 20% increase in precipitation. That translated to a 14% increase in the flooded area, but also a 30% increase in the number of homes flooded.
Right.
And it's those homes that are at the edge of the flood that, might not have been flooded without climate change. And so that's how this kind of finding translates into the real world about what happens to people.
Because it passes a threshold, right? You add that extra rain due to climate change, and then thresholds that would not have been reached are reached. So an example that I always think about is the Battery down in the southern part of Manhattan, right? And this is not flooding rain. This is from storm surge, but it's similar, right? The wall is built, let's say 10 or 11 feet high. So if you get a storm that's not quite as strong, that only produces 9 feet of storm surge, you don't get any water that overtops the wall. But then all of a sudden, now you get 1 or 2 more feet of storm surge, and the water comes over the wall into the subways, into the buildings. And so you go from having very little damage because you didn't get any flooding because the wall protected you, to getting catastrophic flooding because that threshold was breached by another foot or 2 worth of storm surge. Again, you're not talking about storm surge. You're talking about freshwater flooding here. But it's the concept of thresholds that I think that specific analogy helps people to understand.
It's interesting you bring that up because there is a lot of confusion about this kind of business with this causal inference and causality, what caused what. And, we've been very careful in the scientific literature to express things in terms of probabilities. This storm is 10 times more likely or 100 times more likely, or climate change increased the rainfall by 20%. But when you get to these kinds of impacts where there's a threshold, and this, I need to write this. I'm writing a new article. I'm going to highlight this concept that all of a sudden the causality becomes binary. Either climate change caused it or it didn't, when you have a threshold.
Right.
The one in the news right now are these dams in Libya. And there's a lot of, I think, confusion about this. I mean, what we don't know is whether these storms would have broken, whether these dams would have broken without climate change. If that's the case, then climate change didn't cause the flood.
Right.
And that, that's been confused, I think, a lot. And so I need to write more about that.
Right. So let's move on to the next study, because you actually produced another study back in April, which I think was a very interesting study, which basically said that you did computer simulations using, synthetic hurricane tracks, I assume, but you can get into more detail, which basically said that steering currents seem to be changing around the southeast U.S. and the Gulf of Mexico. And in addition, that wind shear seems to be weakening as well, especially as we head into the future. Is that correct? Can you tell me more about that paper?
Most of what you said is correct. One thing is really incorrect, and that is that the heavy lifting on this and the ideas and the concept all go to the lead author, Karthik Balaguru from the Pacific Northwest Lab, who's a brilliant scientist that I felt privileged to be invited to be part of this study. And in fact, of these two papers, I consider this one far more important. The Hurricane Ian paper, actually, we had a lot of trouble in reviews. People said, well, this is boring. You've already done it. Mm-hmm. And it's true, which is why we framed it as this is how to do things in operational. But in this paper, we find that we found a number of things that are very disturbing. Now, it's not an attribution paper, it's a projection. And so we're not looking at trends that are in the observations yet. That I think is maybe the next step. But the projections tell us what we might expect to see, or maybe already has happened. And that's that the risk, as you show in this picture here, is that there's an increased risk of hurricanes making landfall along the Gulf Coast into Florida and a little bit up to the East Coast until you get up to the mid-Atlantic and the Northeast, where the risk of a landfalling hurricane is reduced. And the primary reason for this is a change in the steering winds. And Karthik was able to trace this to a westward shift of something called the NASH, the North American Subtropical High, which is a persistent high pressure system off the to the east of Florida. And that's moved a little to the west, or is projected to move a little to the west, and has this profound change in the risk of a landfalling hurricane.
I need to clarify this even for myself. So in the paper, I read that it was something about a cyclonic flow in the western part of the Atlantic Ocean, but you're mentioning an area of high pressure. So essentially, there's
those two are connected. Those two are
both of them. So it's essentially both pressure systems.
It's a change in the circulation, and that's what makes this paper so important. Is a lot of my colleagues have been saying, without, I think, a lot of evidence, that changes in atmospheric dynamics are really a big factor in changes in extreme weather. And I've been part of another group that's saying, well, yeah, that's interesting, but the biggest thing that is the changes in the thermodynamics, the changes in the temperature. And that Hurricane Ian result is only due to changes in the temperature, right, not anything else, by design. But in general, that's the case, is that these thermodynamic responses are much larger than the
So for folks at home, thermodynamic just means heat and moisture, right?
So heat more than the winds.
Right.
And so so this paper finds a result that I think is novel, that that the change in the winds, through the movement of this Nash object, has an impact on extreme weather, in this case, hurricanes. And so I find this paper to be an extremely important paper. Like I said, Karthik's a really brilliant guy. What he did is he took the climate models and then had a synthetic track model similar to what you did with the Columbia folks, and did this analysis. And so the changes are all on the Gulf Coast and the Lower East, but the largest are the northern part of the Gulf and in Florida.
Yeah,
and so that should be concerned to your viewers. You mentioned the wind shear. That is almost tangentially discussed in this paper, but actually that's important too. Because, well, in two ways. One is that we already know that the coastal areas are warming somewhat more than the open ocean, and that means that the potential intensity increases, so the risk of a perfect storm being stronger is increased. And then you have the wind shear being decreased, which means the odds of a perfect storm happening are also increased. And so you've got two things going on that are three things are going on.
Yes, it's a triple. It seems like a triple threat there.
It's a triple threat. You've got the change in the winds, the change in the Nash, the change in the circulation, the change in the wind shear, and then you've got this accelerated warming in the waters closest to land. And so that should be, I don't want to sound like an alarmist, but boy, this is pretty alarming.
Right. And so for the folks just tuning in, basically we see the red, correct me if I'm wrong, Doctor, we see the red, that's an increased risk for hurricanes in the future. Is that right?
Yeah. And that's just, overall hurricanes. But I think what we also have to understand is those are the same regions that have an increased risk of a Category 5.
Right. Right.
Like, Hurricane Ian.
This is one of the first studies that I've seen that really quantifies basically whether we're going to see less risk or more risk in the Gulf of Mexico in the future, and why we may see more risk, it turns out, more risk. And you're saying it's due to changes in steering, changes in the warmth of the water close to the coast, and also decreases in wind shear, which would then allow these storms to potentially intensify right up to landfall. And it seems to me that these are pretty robust findings. I can see the X's. Are those X's underneath the red, which usually means statistical significance to the 95th percentile?
Yeah, indeed it does.
Right, right. Okay, well, I think that that is fairly alarming. Now, what is the next step in this particular study? Because what you're basically telling me is this particular study finds this. Do you feel like if other studies are done, they're going to find something similar, or could this just be a fluke that maybe it's not the case that hurricane? Is there something? What could go wrong? Is what I'm asking. What could go wrong?
Well, lots of things can always go wrong, but if we thought this was a fluke, we would not have submitted it to Science Advances, which is.
I only say that because people are watching from Florida and the Gulf Coast right now, and they don't want to hear that their hurricane risk is going to increase in the future.
I don't want to tell them that. I would love to be wrong. I see no reason to think I am.
That's
that's why this is so alarming. I mean, I'd love to have somebody look at this and find something wrong with it.
Right. Okay. Well, it's been out. The paper's been out for several months now, and if anyone hasn't found fault yet,
this takes a while, of course. But this is the scientific method, of course, in that you put out your ideas. The reviewers, a limited number of reviewers, who are expert in the field, take a shot at it. You make an improvement, based on their criticism. Sometimes the criticisms are so severe that the paper's rejected. In this case, they weren't actually too severe at all. And then it's out there. And a shocking finding like this gathers attention, and that means that other people will start to look at it in their ways and either find support or not. That'll take some time, but I see no reason why these results will not bear fruit. Well, that's not the right word, but
this is not only a concern because people live here and they're scared of hurricanes, rightfully so, but they're also concerned about their homeowners insurance policies going up. I just wonder what kind of research is in the hands of these insurance companies. You know, obviously they see your study and your colleagues' study. They probably have their own studies. We see that a lot of these insurance companies are pulling out of the state of Florida right now, or in premiums are going up very, very quickly. And a study like this just is not very encouraging because it makes you believe that the insurance companies are seeing the writing on the wall and they are leaving because they're afraid of the future.
Well, my fire insurance just doubled. That's
right. And you're in California.
In California.
Right.
Yeah, insurance is a complicated business, of course, that I'm not in. But you know, they also know, not only do they see these papers, but they also know how much they've been paying out. You know, and that's probably the most important thing, is that they've had major losses in a number of storms: Hurricane Michael, Hurricane Ian, Hurricane Idalia. They're the ones that, you know, come immediate to mind to me. And you know, one of the things that, you know, hurricane insurance companies price risk, and you know, they are regulated, and sometimes they feel like they can't, you know, price the risk appropriately, but other times they just don't know how to price the risk, and I think that's another factor.
Yeah.
But there are, you know, and they have their own catastrophe models. But I have some questions for them, and maybe you know the answer to this. So Hurricane Ian had both saltwater flooding through the storm surge in Fort Myers.
Yeah.
And then the freshwater flooding that was, correct me, is this like outside of Tampa, was that?
Just south of Tampa. So it's on the southern side of Sarasota County, and then into Hardy County and southern Polk County, where, it was something like 20 inches of rain in about 6 hours.
And so the area of the freshwater rain-driven flooded area is much larger than what was impacted from the storm surge, just because.
That's correct. Yes. Yeah.
But, you know, the types of damage is very different.
Right.
You know, in Fort Myers, you know, things were washed off, you know, out to sea.
Right.
In the freshwater flooding, you know, you had a flood in your house, but the structure still, in most cases, I hope, was still intact. And so, which is the greater financial damage? Which is the greater insured loss? This is not a number that I've been able to
I don't know the answer to that question. Actually, it's a very good point that you make, because a lot larger of an area was flooded by substantial rain, where there were few to several feet of water in people's homes, especially in places like Northport, which is in our viewing area, actually. Whereas a much smaller area like Fort Myers Beach and Santa Barbara Island and Captiva Island were hit by the surge, and some of these areas were just wiped clean. In other areas, the structures survived. I don't know the answer to that question. That's a good. I
asked this question because I'm very interested in trying to determine how much climate change cost. And so, you know, the 20 inches of rain, you know, raised the flooded so many more houses. You know, that has a value. In Hurricane Harvey, where, you know, it was only rain driven, our estimate of that 30% more homes was that climate change cost an additional $40 billion.
Right. Well, I have a suggestion.
Not a small number.
There's a guy I know who is a meteorologist and also works for an insurance company I don't know if you've ever collaborated with him, but I know he does collaborate on papers, and he'd probably be the perfect person for you to talk to about this.
That'd be cool.
Yeah.
I'd like to get, you know, some feeling about, you know, small amounts of catastrophic damage versus large amounts of less catastrophic damage.
Right.
Which is the bigger loss.
Well, you're getting into the weeds. I can't get into the weeds like you do. I'm glad that there's someone like you around to do that for me.
It's what we do.
Dr. Wehner, I really appreciate your time very much. Today is, of course, the anniversary of Hurricane Ian striking the southwest coast of Florida, part of my area, which, you know, again, over 20 inches of rain, wind gusts over 150 miles an hour, 15 feet of storm surge. We hope to never see that anytime soon again. But I want to thank you for being a guest on today's Climate Classroom.
Well, thank you. And my best wishes go out to the victims of both this storm, Hurricane Ian and Idalia. You know, to me, it's an academic thing, but to them, it's real. And that's real suffering. And my heart goes out.
It is a life-changing experience for people where oftentimes, if you remember Hurricane Andrew, people will say, before they'll speak about their life and, well, before Andrew and after Andrew, it becomes kind of a pivotal moment in their life where kind of everything changes for them. And I know that happened to so many people across Southwest Florida and the southern part of our viewing area as well. Again, thank you, Dr. Wehner. I appreciate it very much, and I'll be in touch soon.
Thank you.
And I want to thank everyone at home for tuning in for today's Climate Classroom. We'll see you again next week where we discuss the biggest and best climate topics that are out there right now. Again, you can watch us on our Facebook page, which a lot of you are probably watching us on right now, also on WFLA.com. And we also send this to YouTube after the episode is done. In addition to that, you can also listen to us on Spotify or Apple Podcasts as well. From our stream center here at WFLA, I want to thank you for tuning in, and I'll see you again soon.
Watch or listen to Jeff's Climate Classroom, powered by Armor View Window and Door on WFLA social media platforms, and find Jeff's climate reports on WFLA.com.